Welcome to Unit 6, Inference for Categorical Data on Proportions. In this video, we're going to tackle topic 6.9, justifying a claim based on a confidence interval for a difference of population proportions. So we already learned how to find a confidence interval for a difference of population proportions. Now we're going to really kind of just dive a little bit deeper. In this video, we're going to talk about several different things that just kind of look at the details a little bit more. And a lot of them should sound familiar when we talked about confidence intervals for a single population proportion. Now we're just going to be kind of directing that towards the difference of population proportions. So what we're going to talk about is, what does C % confidence mean? The more times you hear this from me, the better, because this is typically a multiple choice or even an FRQ question on the AP Stats test. I want to make sure that you truly know what a confidence level means. We want to talk about the width of an interval. We want to talk about how to correctly interpret an interval, which we already talked about in the previous topic. But boy, it's so important to understand how to interpret an interval when you are looking at the difference between two population proportions. So we're going to kind of reemphasize that. And then we're going to finally talk about how to justify a claim with a confidence interval, which is the name of this video, is the name of this topic at least, but it's very, very simple. Should make a lot of sense. All right, let's first make sure you know what C % confidence means. So a very common level of confidence is 95%. So what the heck does 95% confident really mean? Well, in a nutshell, it means that in repeated sampling with the same sample size, approximately 95% of confidence intervals created will capture the true difference between the population proportions. Make sure you understand that your confidence is not a probability or it's not a chance. The idea all stems from that sampling distribution. Remember that sampling distribution, as long as all conditions are met, has the true difference in the middle. The true difference between the two proportions go in the center. Right? And then we go down and up by our standard deviation. And the whole idea is, if we're 95% confident, that means that there is 2.5% at the bottom that would be significantly low, 2.5% at the top that would be significantly high, and 95% of differences are in the middle. Remember, sampling distributions don't just show one thing. They show many, many, many possible differences. So our difference that we find between our two samples, you know, if you had to put your money on where you think that difference fell, it's going to fall right here in the middle somewhere. It would be really weird to fall towards the bottom, or really weird if it fell at the top. That's why we're very confident that our sample is one of the 95% of sample differences that fall in the middle. Remember, sampling distributions show you all possible differences. Even though we don't know the true difference that falls in the center, we know our sample difference, and the difference between our samples should definitely fall in the middle. And the idea is that, yes, we only have one interval. At the end of any of the problems that we've done, we only have one interval. But there are many intervals, because each proportion, the one from population 1 and the one from population 2, each proportion could vary, which means that the difference could vary a lot. Right? There's a whole lot of possible differences. But we're very confident that our difference is one of the ones in the middle 95%. Hence, when we create our interval, we will capture the truth. And again, if you think about it on a simple scale, if there were 100 intervals created based on 100 different differences, 95 of those intervals will contain the truth, the true difference, 5 will not. So that's kind of the idea, guys. It's really simple. It's not overly complicated. But, you know, what's there in bold, black, and white there at the top, that's kind of the big answer that you're going to get when somebody talks to you about what does 95% confidence mean. All right, let's talk about the width of the interval. All of this should sound very familiar. The idea is that, you know, we would always prefer a more narrow interval, right? A more narrow interval is going to be more accurate, but we want to maintain high confidence. So first, let's think about how the level of confidence plays a part. The level of confidence certainly plays a part into how big or how small your interval is. Simply put, more confidence produces a wider interval. If you're going to go from 99% to 95%, or I'm sorry, if you're going to use a 99% instead of a 95%, then your Z star is going to be bigger. And a bigger Z star is going to produce a bigger interval. So, you know, all things being equal, more confidence will be a bigger interval. Another way, another number at least, that affects your margin of error, your intervals width, is the sample size. Bigger samples will always produce a more narrow interval. The sample sizes are in the denominator of the standard error formula. Hence, bigger samples will make the overall margin of error smaller, which is going to produce a more narrow interval, right? That's a very simple topic that we've been learning for a while. Bigger samples are flat out more accurate. So a bigger sample with more accuracy is going to lead to a smaller margin of error, hence a more narrow interval. So the idea is that we don't want to lower our confidence, because if you lower your confidence, you will get a more narrow interval. But I don't want to do that. I want to be high confidence. I want to have 95, 98, 99% confidence. So if you want to maintain a high level of confidence, but still produce a very narrow interval that is accurate to what the truth is, bigger sample size will do it. So that's all a recap of something we've already learned a little bit ago. Just make sure that you really understand those ideas. All right, now let's talk about interpreting an interval for a difference. Now, a confidence interval for the difference between two proportions, and I'm being very vague here, very, generic here, P1 minus P2. So if I have a proportion that's true for all of population 1 minus a proportion that's true for all of population 2, then only 4 things can happen, right? That difference could only produce an interval of 4 options. Either the entire interval is negative, or the entire interval is positive, or the low end is negative and the high end is positive, or the low end is positive and the high end is negative, okay? What matters most is that you understand what the numbers say in terms of comparison, right? Because at the end of the day, we're comparing 2 things here. We're comparing population 1 to population 2. So don't just inform, you want to compare. So the idea is if my entire interval is positive, that means that proportion 1 from population 1 would always be bigger. Because if I take P1 and it's always going to be bigger, then a bigger number minus a smaller number is always going to produce a positive. So if my entire interval is positive, that gives me a lot of confidence that the proportion from population 1 is going to be bigger. If the entire interval is negative, then that would happen if your proportion from population 2 is always bigger. Because the only way you're going to subtract these in this order and get a negative is if the second number is bigger. Now, if one end is positive and one end is negative, either way, it just means that they're alternating. For example, if the low end is negative, that means that, again, proportion 2 from population 2 would be bigger. If the other end is positive, then that means proportion 1 from population 1 is bigger. Now, this is kind of a hard thing to talk about generically, so let's look at an example that's a little bit more specific, and it's actually a little bit easier to discuss. Imagine if we were trying to figure out the difference between the proportion of boys that like school lunch and girls that like school lunch. And we were going to find this difference in terms of taking the boy proportion minus the girl proportion. Now, here are 4 different intervals, and what matters most is that you understand how these intervals allow me to compare. This first interval is all positive. All positive means that with, who knows what level of confidence I have. Let's just say that these are all 95% confidence intervals. That with 95% confidence, I know that the boy proportion is going to be 15% more than the girl, or to as high as 23% more than the girls. So this interval does give me a lot of confidence that the proportion of boys who like school lunch is bigger than the proportion of girls at school lunch. How much bigger is the question? Anywhere from 15 to 23% bigger. If the entire interval is negative, that means that my proportion of girls that like school lunch is going to be bigger. Again, how much bigger? Well, anywhere from 12% bigger to 26% bigger. Now, again, where do the negatives come into play? Well, again, just think. If I want this difference to be negative, the proportion of girls has to be bigger, or you could view it as the proportion of boys has to be lower. Either way, it's the same thing. I could look at this as the boys is 12% lower to 26% lower than the girls, or the girls are 12% higher to 26% higher. But you got to understand how the negatives come into play. Now, a difference like this that's half negative, or not necessarily half, but the left side's negative, the right side's positive. Now, this difference tells me that, well, okay, let's make sure we process this. The girls could be 4% more than the boys, or the boys could be 8%, because the positive 8% is with the boys are 8% more than the girls. The negative 4% is if the girls are 4% more, or again, boys 4% less than the girls. I'm trying to go slow so you can understand this. I think it's pretty easy, but yet, sometimes taking time to understand it is important. Now, again, the other thing that can happen is the interval looks like this, but it's kind of the same conclusion. Just make sure we understand positive versus negative. Positive means the boy proportion is 9% more than the girl proportion. Negative means that the girl proportion is 7% bigger than the boy proportion, or the boy proportion is 7% less than the girls. So, the important thing to understand here is if the entire interval is positive, that's giving you a lot of confidence that boys have a higher proportion of boys like school lunch than girls. If the entire interval is negative, that's going to give you a lot of evidence that the proportion of girls are more than the proportion of boys that like school lunch. When your interval is split, negative and positive, not even split perfectly in half, just negative on the left, positive on the right, or vice versa, that's showing you that either population, boys or girls, could be higher than the other. And what we're going to talk about in one moment is that what you'll notice in both of these bottom intervals is that 0 falls into them, which means that there could potentially be no difference between boys and girls. Okay? And that's where we finally get into this next part about justifying a claim. This is the importance of 0. Typically, when researchers are comparing the difference between two population proportions, they really just care about, is there a difference? Is there a difference between these two population proportions? Or they're looking for, is one per population proportion bigger than the other? Like, is the proportion of boys bigger than girls, or vice versa? So they simply care about, hey, is there a difference? Don't really care if one's bigger than the other. I just care about, is there a difference or not? Or do they specifically think that one population is bigger than the other? Now, in either of these scenarios, what matters most to the researchers is 0, because 0 becomes the key value to look for. If 0 falls in your interval, then again, there could be no difference. Yes, one side's positive, one side's negative. So the boys could be more, the boys could be less, the girls could be more, the girls could be less. But that's great. But 0 falls in there, so maybe there's no difference. So, if you're asking the question, is there a difference between boys and girls? If 0 falls in that interval, then saying that one population is bigger than the other is not a smart statement if 0 is in the interval. Okay? So if we go back to these examples here, if I'm looking at these two bottom intervals that are in blue, if I said, hey, is there a difference? Are boys or girls, is one bigger than the other? I'm going to say no. I mean, at least there's no justification of it. At the end of the day, this first interval shows that boys could be 4% less, or girls could be 4% more, or the boys could be 8% more, the girls could be 8% less. But you know what? 0's in an interval too, so maybe there's really no difference. Now, if an entire interval is all positive or negative, then that does give you evidence that there is a difference. For example, the top one circled in red does give me a lot of good evidence that a larger proportion of boys like school lunch than girls, because 0's not in the interval. So the question is there a difference? And if 0 falls in the interval, there might not be a difference. I don't care where it falls, top, bottom, doesn't matter. If 0's in there, there could be no difference. So saying there's a difference is wrong. All right, let's look at an example here. This was actually an example that we saw in the last topic video. But essentially, we were looking at the difference between the proportion of California adults that are unemployed and Pennsylvania adults that are unemployed. If you recall, the sample of California had 3.2% unemployed, Pennsylvania 2.8%. Now, what I did was I was looking at the proportion of California minus the proportion of Pennsylvania. Now, my sample difference, right, our sample difference, which I did Cali minus Pennsylvania, was the 3.2% minus the 2.8%. That's 0.4% or 0.004 as a decimal. Now, the interval we got was negative on the left, positive on the right. Now, the proper interpretation of this interval means that the proportion of California adults that's unemployed could be as high as 2.52% higher than Pennsylvania to potentially 1.72% lower than the proportion of Pennsylvania. Or you could view that as Pennsylvania's 1.72% higher. Remember, all these intervals could be viewed from the perspective of California or Pennsylvania. So if I'm viewing this interval from California's perspective, They could be 1.72% lower than Pennsylvania to 2.52% higher. If I view this from Pennsylvania's perspective, Pennsylvania could be 1.72% higher to 2.52% lower. But the idea is there a difference? Can an economist look at this interval and tell me for sure that there is a difference between the California and Pennsylvania proportions of unemployed adults? And the answer is no. Zero falls in this interval. There could be no difference. Remember, I'm 99% confident that the truth is in this interval, but where is it? I got no idea. So this interval clearly tells me that California could be higher, Pennsylvania could be higher, or there might even be no difference between the two. So this interval does not give me justification that there is a difference. So if I'm looking for a difference, this interval is not going to give me what I need because this interval shows that there could be no difference. So that's the idea of justifying a claim, right? Usually somebody's going to say, there's a difference between the two populations. And this interval clearly doesn't say there is. I mean, there could be, but there could not be. California could be higher, California could be lower, or there could be no difference. That's the idea of what happens when zero falls into your interval. So make sure you understand that concept, right? That's kind of a big thing that pops up. A lot of times that could be on the AP test in terms of multiple choice question or even a free response is, when we're asked to find an interval, we do our steps, we get the interval, but sometimes really deep diving into that conclusion, truly understanding what that interval means to us is far more important than anything that came before it. Okay, so hopefully you understand this very simple concepts in this video. The idea about bigger sample sizes will make your interval smaller, more narrow, smaller margin of error with a high level of accuracy still. Make sure you understand what 95 or 99% confident means. It's all about intervals, right? There's, we ever just find one interval, but there's millions of them out there because these sampling distributions are massive. So the idea is that we're confident that our sample is one of those many intervals in the middle that contains the truth. And then lastly, please make sure you truly understand how to interpret these intervals. It gets a little bit tricky when you're looking at the difference between two, but keep in mind, we always want to make sure that we're comparing. That's the whole point of looking at two different things is you want to compare them. So make sure you talk about statements and you express statements that are in context that are truly comparing. Higher, lower, bigger, smaller, no difference. There is a difference. Boys are higher, girls, use those types of statements to truly make sure you explain what you're seeing. All right, guys, that's it for topic 6.9.